Suppose we want to divide this line segment into 5 equal pieces. What we do is we draw a line through one of the endpoints at some angle to this line. It doesn't matter what the angle is. So I'll pick this endpoint here and I'll draw a line. The next thing you do is you put your compass point at this point and mark off an arc on this line here so that the radius is any radius. It doesn't really matter. So I'll make it here. Then we note the point of intersection here of the circle and the line. Next, we mark off line segments of length equal to the radius of this circle down along this line. We want 5 of them. So here's one of them. So now we have 5 equal line segments. So this segment equals this segment here, which in turn equals this one, and this one, and this one. The segments are equal to the radius of this circle. So you just step off lengths on this line with your compass. So we want to step off 5 lengths here. So we want to divide the red line into 5 equal pieces. Next, we join this point here up to the end of the line segment. And we draw lines parallel to this line through these points. So I want to draw a line through this point parallel to this line here. Whoops. Now the red line has been divided into 5 equal line segments. I'll just quickly mention a proof for why this construction works. It's based on an earlier theorem about a line in a triangle drawn parallel to one of the sides of the triangle. So we could just look at this triangle here. We know from the construction that the distance of here to here is equal to the distance of here to here, and I'm calling these distances A, and of course these 3 are also A. Now we have to prove that C equals D, but we can apply our theorem, which was covered in an earlier video, which says that if we divide A by A, we'll get the same answer as dividing C by D. So that's only true if this line is parallel to this third side of this triangle here. We're just looking at this triangle. So this ratio formed from this line on both sides of the triangle is the same. But A divided by A is just 1. So we see that C over D is equal to 1. And that tells us straight away that C must equal D. Of course, we can extend that result by considering a larger triangle. Say the triangle whose corner is here, here, and here. So we could look at this side here, divided by this side here, and set it equal to this distance divided by this distance here. So we proved that in an earlier video as well, that if we have a triangle and we have a line parallel to one of the sides, if we divide this by this, we'll get the same answer if we divide this distance by this distance here. But the distance from here to here is 3A. Now let's call the distance from here to here E. We know that C is equal to D, so we can replace this D with C. So 3A divided by 2A must equal E divided by C plus C, which is 2C. So we can cancel the A's here, and we can multiply both sides by 2 to cancel the 2's, and we get E equals 3C. So the distance from here to here is 3 times c. So the distance from here to here must be c. So we've shown that these three lengths are the same, and we can continue on. We can take a look at the next triangle, and we can do something similar to prove that the distance from here to here is also equal to c. And extending further, we can prove that this distance here is also c. So this construction works to divide a line segment up into, say, 5 equal pieces. We just draw a line through one of the endpoints and mark off 5 equal segments. Or if we want to divide it into, say, 3 pieces, we mark 3 equal segments down this line and connect the endpoint up to the endpoint of the interval that we want to divide, and then draw in parallel lines.